In the last videos, we have seen how to create the ND arrays, then even how to access the elements from the ND arrays. In this video, we will see what are the various operations that are supported by the Numpy package on the ND arrays. So, of course, it supports the attribute n dimensional, then item size, d type, reshape, slicing. You can see the line space, min max functions, then the sum function, then square root, standard deviation, so hstack, vstack. So, all these are the popular and useful operations that are supported by the Numpy package. Now, we will see each of these functions and the operations in detail, so using some examples.
For the illustration of the examples in this video, we consider three array objects, the A1 which is a one-dimensional array, A2 which is a two-dimensional array, and A3. So, here you can observe it is a three-dimensional array object. So, now let us see how to apply various properties on these array objects. So, if you would like to check how many number of dimensions are there in an array object, you can use the attribute ndim. So, which stands for number of dimensions. Here n stands for number, dim stands for dimensionality. So, how many number of dimensions are available in an array object, you can check using the property ndim. Here you can observe A1 is an array object with single dimension, A2 with 2 dimensions, A3 with 3 dimensions. So, that is how you can use ndim to check the number of dimensionality of an array object. So, if you would like to check whether the given variable is related to the array object or some other object, you can use a type method. So, type is basically a method which is used to check the type of a variable. So, here you can observe type of A1. So, here the type of the variable A1, A2, A3 are ND array. And now let us see some other additional properties related to the arrays. You can use the shape attribute to check the size of each dimension in your array object. So, if you observe A3 is a three-dimensional array object, right? And for each dimension you can get the size of the dimension using the shape object. A3.shape returns a tuple with 3 elements indicating the size of each dimension. So, that is how you can use the shape attribute to get the size of each of the dimension of the array object. And another attribute that allows you to check the number of total elements in the array object is a size attribute. In the array object A3, it's a 3 by 3 by 3 object, right? So, it contains a total of 27 elements. So, that is how size attribute allows you to check the total number of elements available in the array object. So, you have another attribute which allows you to check the type of the elements in the array object. If you remember, Numpy array objects are the homogeneous type elements. That is, all the elements that are stored in the Numpy array objects must be of the same type. And what type they are belonging to, if you would like to check, you can use the attribute d type. D type stands for data type. So, here if you observe, all the elements of the object A3 are belonging to the integer type. So, we will discuss more details about the data types that are supported by Numpy in the other video. So, that is how you can check the type of the elements of the array object. And there is another attribute which allows you to check the total number of bytes that are occupied by the whole set of elements in the array object. So, n bytes stands for the number of bytes. So, A3 dot n bytes. So, here you can observe it returns 216 bytes. That indicates that, so A3 contains 27 elements and the total memory occupied by all these 27 elements is 216. To get the transpose of the given array object, you can use T attribute. Here you can observe the original array object A2 is a two-dimensional array object with 2 rows and 3 columns. So, if you would like to apply a transpose operation on that, you can call the attribute A2.T. So, now you can observe all the rows in the array object A2 becomes the columns and all the columns becomes the rows. So, that is how you can get the transpose of the given array object using the T attribute. Now, let us see some of the operations that can be performed on the array objects. So, if you consider A3, which is a three-dimensional array object of size 3 by 3 by 3. So, you can flatten this array object using the flatten method. So, here flatten indicates that an n-dimensional array object can be converted to the one-dimensional array object using the method flatten. So, if you observe A3 is a three-dimensional array object. On applying the flatten method, you can observe it is returning a one-dimensional array object. So, that is how using the flatten method you can convert an n-dimensional array object into a vector. The flatten method takes one argument, order, and the values that can be passed to the order argument are either a C or F. A C indicates the flattening is done in the row major order, and F indicates it's done in the column major order, and the default is a C. That is, the flattening operation is done in the row major order. So, first 1, 2, 3 is taken, then 4, 5, 6, then 2, 5, 1 if you observe here. So, that is how row wise flattening is done when you are using, so no argument or order as C. And in case of the column measure order, that is when your order value is f, then so you can observe that it's done in the column measure order, that is first the column wise values are considered and then the row wise values are considered later. So that's how you can convert any n-dimensional array object into one-dimensional array object. Another method that supports the transformation of multi-dimensional array to one-dimensional array is the ravel method. So if you observe, A3 is a three-dimensional array, and when we apply ravel, you can see it is converted to the one-dimensional object. So that is how you can either use the flatten method or the ravel method to convert the multi-dimensional array objects to the 1D array objects. To create a copy of the array object, so copy method is available. So if you observe A3.copy, so this array A3 is copied to another array A4. So now A4 is created as a copy of the array object A3. Let's consider A1 with 3 values. It's a one-dimensional array. If we would like to fill all the elements of an array object with a specific value, then we can use the method fill. So here I am going to fill the entire array object with the value 10. Here you can notice that the array object A1 is filled with 10 at every position. So that's how fill can be used to fill a specific value at every position. Reshape is another method supported by Numpy to reshape the available array object. If you observe the array object A3, it's a three-dimensional array object of size 3 by 3 by 3. Now I would like to reshape that to a two-dimensional array object. So I can use the reshape method by passing the number of required dimensions as arguments. Here I would like to convert this 3D array object to the 2D array object. Hence I am passing 2 arguments to the reshape method. 9 and 3 are the dimension size. So now if you observe, the array object A3 is converted to the 2D object. That is how the shape of an array object can be converted using the reshape method. One thing you need to keep in mind is, while reshaping any array object, the size before and after must be the same. So that is, here if you observe, the array object is of size 3 by 3 by 3. That is, the total number of elements are 27 before reshaping, and I am going to reshape this array object to the two-dimensional object of size 9 by 3. That is, the resultant number of elements are also the same, 27. So that is how, while reshaping the array object, the sizes must be the same. So accordingly, you need to provide the arguments to the reshape method. Squeeze method is an interesting method which allows us to remove the dimensions which are of size 1. Here I am creating an array which is a three-dimensional array. Its size is 1 by 3 by 1. Here I would like to remove all the axes whose dimensions are 1. Then I can simply do it by using the squeeze method. So np.squeeze of x, and I am assigning that to y. And after squeezing, what is the shape of the array object? Let's check that. So here you can observe that. So after applying the squeeze operation, the array is of a one-dimensional array object, because so in the three-dimensional array object there are 2 dimensions with the length 1. So all those are squeezed out and the resultant array object is converted to the one-dimensional array object. So if you notice, you will not be losing any information from the original array. So all the elements will be available in the resultant array object, but all the dimensions which are of length 1 will be removed from the array object. That's how squeeze method can be used. And if you would like to squeeze any specific dimension, so that is also possible by passing the access argument to the squeeze method. So here if you observe the X array object, so it's a three-dimensional array object of dimensions 1, 3, 3. It's a three-dimensional array object of size 1 by 3 by 1. Right? So now I would like to specify in which dimension I would like to squeeze the array object. That can be done by passing the access argument to the squeeze method. So here you can consider the first dimension as a 0th dimension. This is the first dimension, this is the second dimension. So now I am passing access equal to 0. So then what happens? If the size of the 0th dimension is 1, then so that will be removed. So you can notice here the 0th dimension is removed, and hence the resultant array object is of size 2-dimensional. And similarly in this case I am squeezing out the first dimension. So by specifying access equal to 1. As there are no dimensions with the length 1, so it's throwing an error. So you should be little careful while using this squeeze method. So as there is a dimension whose length is 1, so that specific dimension will be removed from the array object. So that's how squeeze method can be used to squeeze out the dimensions which are of size 1. And now let's see how we can apply the sorting operation on the array objects. So you can simply use a sort method, and the sort method takes 2 different arguments, the access and kind. So now let's see if we do not pass any specific arguments, so then how it works, what are the default settings for this axis and kind. So we'll see that. So let's consider the one dimensional array object and let's sort it. So here I created the array object X whose dimension is 1, and on this 1D array object I'm applying the sort method, and after sorting you can observe that the original elements are not sorted, but after sorting you can see the elements are sorted in ascending order. So now let's create a two-dimensional array object for our illustration. So here you can notice that it's a two-dimensional array object of size 2 by 3. So there are 2 rows and 3 columns. And now let's try to apply the sorting operation on this 2D array object. And here I am passing the access value as 0. Here axis equal to 0 indicates the sorting has to be done column wise, and when you provide the axis value as 1, then the sorting is done in the row wise order. So here I am passing axis value as 0, so the elements are sorted according to the column wise. You can observe every column in this array object are sorted. So that's how, so according to the column wise or the row wise elements have to be sorted, you can mention that with the axis argument. So now let's sort the array object based on the rows. So I am creating the same array object A2. So this is the two-dimensional array object. So now let's sort this according to the row order. So to sort the elements as per the row, you need to pass the axis value as 1. So when you pass the axis value as 1, the elements are sorted row wise. That is, every row by itself it is sorted. So here it is 1, 3, 2, but when you observe, the row is sorted. So each row itself is sorted. And there is another argument that can pass to the sort method, that is kind argument, which indicates the type of sorting that has to be used while sorting the elements. You can pass either quick sort, merge sort, heap sort, or the stable sort, and which is optional. The default argument for this kind argument is the quick sort. Let's look at the next operation, how to join the arrays. For joining the arrays, you can use either concatenate or hstack or vstack methods to join multiple arrays. So concatenate method basically allows you to join a sequence of arrays along an existing axis. A hstack allows you to stack the arrays in sequence horizontally, that is, column wise it allows you to stack the arrays, whereas vstack allows you to join the arrays vertically. Now let's have a look at these examples. So consider A and B as the two-dimensional arrays with the elements 1, 2, 3, 4 in A, 5, 6, 7, 8 in B. So now let's concatenate these two arrays and see. So concatenate method, so I am passing these two arrays A, B, and I am passing the axis attribute as none. When the axis attribute is passed as none, then all the elements in all these arrays are transformed into one-dimensional matrix. If you observe 1, 2, 3, 4, 5, 6, so they are concatenated as a one-dimensional vector. And when you pass the axis value as 0, then the arrays are concatenated vertically. Here if you observe 1, 2, 3, 4, so then after that 5, 6 is added as a new row and 7, 8 is added as another row in the matrix. So that is how axis equal to 0 indicates you are concatenating row wise, where axis equal to 1 does the concatenation of the values column wise. That is, the elements of A and B are concatenated column wise. So that is how you can specify the axis attribute to mention the type of concatenation. When the axis is mentioned as none, then one-dimensional array is created. When axis is equal to 0, then the elements are concatenated row-wise, whereas the axis is specified as 1, then the elements are concatenated column-wise. Now let's look at the hstack method, which allows you to horizontally stack the arrays. So consider the same arrays A and B, which are two-dimensional in nature. Now I am applying the hstack method and passing A, B as arguments to the hstack method. So now the elements are horizontally concatenated. That is, the elements of A and B are concatenated horizontally. So that is how the hstack method works. When you would like to stack these two arrays vertically, then you have to use the method vstack. So that is how, using the hstack, vstack and the concatenate method, it is possible to join two or more arrays together. So far in this lecture, we have discussed various operations related to the arrays. We have seen few of the properties related to the array objects, like how to check the dimensions, then type of the elements, then total size of the array object. All these details, how to check, we have seen. And then we have seen the operations that can be applied on these array objects. Like we have seen the operations such as flatten, ravel, copy, reshape. Then we have seen the squeeze method. Then finally we have seen the sorting method. And we have also discussed the joining of arrays, like how concatenate, hstack and vstack methods can be used to concatenate the arrays.
So now I hope you understand how to use various operations that are supported by the Numpy package on the ND arrays. Thank you for watching this video.